Lecture 14b, killing vectors. Attention now, from the last lecture 14a, we derived, okay, gij dxi dxj at t plus delta t. You see, that's the equation 1, 2, 3 from 14a. This I call ACE over here at t. You see, this is equal here, which means that we preserve distance, angles, and so on, because distance, angle, they are related to the metric. So let's expand in Taylor series. You see, before this, let's multiply gij delta t xk, this over here, times dxi delta t dxi dt, that multiplies this. This here is the expansion, Taylor expansion. This over here is Taylor expansion. Taylor expansion for dxi and dxj. You see, all this, okay, is at t, time t. So, just to make clearer, let's set A, B, C, D, E, and F, just to multiply these factors. So, you just follow the letters. It will be quite easy, you see, just from here to here. So, attention, when I multiply b delta t times d delta t, I can neglect, because delta t square is quite small, okay? It's small, but you can compare it with delta t. This will be smaller. You see, that's easy. So from here, I can write only remaining delta t. You see, that's easy algebra, okay? Then I multiply, okay, these terms. Then this leads to ACE plus delta t that multiply this letter here that's missed, ACF. And this is equal this green one over here, you see? So I can cancel this with this one. So this leads to delta t that multiplies all this is equal 0. You just take a piece of paper and write down. It's quite easy. There is no problem here. Since delta t is different from 0, this leads to this relation here. You see? This is equal 0. So then I substitute A, B, C, D, E, and F. Just substitute by these terms, okay? So it's quite easy. You just plug here, you just plug on this one, you just look at that and copy it to here. So this leads to this relation right there. Now, you see, you have here dxi dxj, dxk dxj. Attention, k, this is dummy indices, okay? I can set here k is equal I, just to compare with this. Then I change the dummy indices, this will lead to this one. It's quite easy, no problem. You see, now I have dxi dxj. The same I can do with this one. You see, this I have dxi dxk. I want dxi dxj. K here is dummy. I substitute k in this case by j. You see, that's a quite easy computation, no problem. So this here leads to GMJ partial XM XJ dXi dXJ XK partial with respect to XK GIJ dXi dXJ and dXi dXJ is equal 0. Since dXi dXJ is different from 0, I can write here equation 4. This equation 4. I just copy from here to there. And this I compare with the Lie derivative of Gij, which I derived in previous lectures. This one is exactly Lie derivative of x of Gij. This is set to equal 0. So this is an equation which involve capital X, which is the flow, the tangent vector. Now I'll continue this, just manipulating a little bit. You see a final this case, Killing vector equations from the next lecture 14C. You see, you're just manipulating here, over here. You see, it's quite easy here, the derivation, okay? Again, take a piece of paper, copy, you see that you understand clearly what I'm doing here. See?